Hey guys, so today I'll be talking about the LeetCode problem on cross lines. So the problem states that we have a list of integers a and b into different lines, and we have to find the number of connecting lines between the elements which are equal, and we have to draw the lines in such a way that do not intersect any other line, and we have to return the maximum number of such lines that can be drawn. So for instance, 1 4 2, we have 1 and 1, 4 with 4, and we cannot connect this 2 with 2 because it will then cross this line, connecting line between 4 and 4. So the number of maximum connecting lines we can get is 2. The way to solve this problem is, if I come to this 1 4 2 and 1 2 4, is we divide this problem into smaller subproblems, like finding the number of connected lines between 1 4 and 1 2 4, and let's say 1 4 2 1 2, because once we get the number of connecting lines in this pattern or in this pattern, we can find the maximum of this 2, and that will be the number of uncrossed lines in this example, because the last element is a dissimilar element. So basically, whatever we get from here and whatever we get from here, so this thing and this line, this line is basically the number of uncrossed lines. And one approach is to solve it using dynamic programming. Why dynamic programming? Because these problems have similar overlapping subproblems. So finding the number of uncrossed lines in between these two patterns is similar to finding the uncrossed lines between this pattern and this pattern, which can be further divided into, let's say, 1 4 and 1 2, and not 1 4, sorry, it will be 1, because the last element here is a similar element. So whatever we find in this part, adding 1 to that will give the number of uncrossed lines in this pattern, which will in turn decide the number of uncrossed lines in our main problem. And this is called similar subproblem, because this pattern might occur in some other path along this path, or it might be a common in this problem or this subproblem. So that's why it's called a subproblem, optimal subproblem basically, and we need to find the maximum number of uncrossed lines in this example. So we solve it by a concept called dynamic programming. And how we solve this is let's rub this off. So let's say what we do is we take this example, 1 4 2, we have 1 2 4. So what we do is we take a matrix of dimensions. Okay, let's use a different color. So we use a matrix of dimension having number of rows greater than the number of elements here, and column also 1 greater than the number of elements present in alongside the columns. And how we differentiate it is we compare this. So this is our main element that we need to consider, this part. So we compare 1 with 1 is similar, so we add 1 to this 0 to the upper diagonal, it will become 1. Next we come to 4 and 1, which is dissimilar. So basically we are comparing 14 with 1, it is dissimilar. We will then use the maximum of the top row just above the element above it and the element just to the left of it, the maximum of those two, that will be 1, because this 1 is there. 2 is not equal to 1, so same thing, 1. So this one means that if we want to compare 1, 4, 2 and 1, the number of maximum uncrossed lines we'll get is 1. That's what this 1 denotes. So thereby what we are doing is basically we are approaching a bottom-up approach. So we are comparing 1 with 1, 1, 4 with 1, 1, 4, 2 with 1, and in this way we are covering the whole pattern. And whatever is like, so by this you can guess like whatever will come here in this cell will be the number of uncrossed lines between 142 and 124, and that's how we approach it. So coming back, so 1 comparing with 2 is not same, so maximum of the 0 and 1, which will be 1. 4 with 2 not same, 1. 2 with 2 is same, so what we do is take this diagonal, upper top left diagonal element, which is 1, and add 1 to that, 2. So comparing between 1, 4, 2 with 1, 2, the number of uncrossed lines we get is 2, which is, as we can see, like this part and this part. So this 2, so that's how we are getting this 2 through calculations in this matrix. 4 with 1 is not same, so this will be 1, maximum of this 2. 4 with 2, 4 same, 2. 2 and 4 is not same, so 2. And this number in this cell denotes the maximum number of uncrossed lines between these two patterns, 1, 4, 2 and 1, 2, 4. So coming back to the code, so what we will do is basically first take a matrix of dimension A length plus 1 and B length plus 1. So that will be DP, meaning dynamic programming. So we call the matrix DP, you can call it anything, but this is for convenience. And we need to create a new array of length A dot length plus 1, fill it with 0, and map each element with the new array of size B dot length plus 1, and we have to fill it with 0 also. Next what we do is like we iterate I equal to 1, I less than equal to A dot length. Mind it, we have the matrix length to be A length plus 1, that's why the last index is A dot length. I plus plus 4, let j equal to 1, j less than equal to B dot length, j plus plus. Okay, so since we are starting from index 1, in order to map it with arrays A and B, we need to decrement the index by 1, so we get the first element. So I minus 1 equal to B j minus 1. This means that dpij will be 1 plus the element in the top left diagonal, which is dpi minus 1 j minus 1, else we need to find the maximum between the element just above it, which is dpi minus 1j, and okay, so this will be math dot max pi minus 1j dp I j minus 1, and that will be our entry for dpij. At the end we need to return dp a dot length and b dot length. Okay, this should work. Let's see. And okay, accept it. Let's submit. Alright, it's passed successfully. So that's it. Feel free to rewind back if you have any doubt in some part of the video, or else you can always put your queries down in the comment section. I know it's a bit complex and something which I haven't covered in my video series dynamic programming. I will of course cover it in the future someday. And as always, if you enjoy this video, do give a like and don't forget to subscribe. I will see you guys in my next video. Thank you.